In this video, we're going to explain how to read analog input control loop diagrams. Every industrial control feedback system has two loops, an input control loop and an output control loop. The analog input loop consists of two major devices, the transmitter and the controller. As you can see, the controller is part of both the input and the output loops. In industry today, the controller is part of a PLC or a DCS. The transmitter is the instrument that converts the signal from the sensor to the process variable or PV signal, which represents the measured variable. The controller is the device that compares the process variable or PV and the desired value of the process, referred to as the setpoint. The analog output loop consists of two major devices, the controller and the final actuator. When the controller completes the comparison between the process variable and the setpoint, it produces an output signal. The final actuator is the device, such as a control valve, that exerts a direct influence on the manipulated variable as directed by the signal it receives from the controller. All right, now that we've discussed the two control loops of an industrial feedback control system, let's look closer at an analog input control loop. Most analog input control loops are connected in a two-wire configuration, which requires a DC power supply. In some cases, the power supply is external, and in other cases, the power supply is part of the PLC or DCS. The transmitter signal is usually 4 to 20 milliamps. Although companies may have different methods of creating analog I/O loop drawings, the transmitter, the controller, and the power supply are common to all. Let's look at some typical analog input loop drawings and pick out the transmitter, controller, and power supply, and see how they are connected to each other. Here's our first example. The power supply, located in a local control panel, is used to power many loops. The transmitter is connected in a two-wire configuration with the power supply and the controller through TBAI02. The controller is one of the channels, input 0, of an Allen-Bradley Compact Logix PLC analog input module. This module is located in Rack 2, slot 26. If you are curious to know more about the analog input module, do a Google search for 1769 IF8. Okay, let's look at another example and see if we can find the transmitter, power supply, and controller. The power supply is found on the drawing on page 4, line 47 of the entire multi-page document. The power supply is used to power many loops as well. The transmitter is connected in a two-wire configuration with the power supply and the controller through wires labeled as 0812 and 0446. The controller is one of the channels, channel 0, of an Allen-Bradley SLC 500 PLC analog input module. Unfortunately, this drawing doesn't give us much of a clue as to where the module is physically located. If you want more details about the analog input module, do a Google search for 1746 SC-NI8U. Let's look at an example of an analog input control loop with a DCS controller. The controller is one of the channels of a Foxborough DCS input module, FBM201. This module is located in the Foxborough I/O cabinet A5. The datasheet for the FBM201 analog I/O module will tell you that the two-wire input and output connections are A and B. The P and ID symbols tell us that the control room HMI will have a graphic for a level indicator LI11632. The power supply is not obvious in this drawing. The datasheet for the FBM201 analog I/O module will tell you that the loop power originates from the DCS and is connected to terminal C. Although it's not shown, the power supply return is connected to A on FBM 201. The transmitter is connected in a two-wire configuration with the power supply and the controller through wires labeled W and B. Let's review what we've discussed. Every industrial control feedback system has an input control loop and an output control loop. The analog input loop consists of the transmitter and the controller. The analog output loop consists of the controller and the final actuator. Most analog input control loops are connected in a two-wire configuration. Regardless of the industry or the company, the transmitter, controller, and the power supply are common to all analog I/O loop drawings. Newcomers to RealPARS have free access to one of our online courses. You can take advantage of this offer by downloading the RealPARS app and selecting the first lesson of the PLC hardware course. Just like this video, the lessons are all high quality and also very easy to follow. Also, for a low monthly fee, you'll get full access to an exclusive library of courses on PLC programming and industrial automation topics, as well as new fresh out of the oven videos each and every week. These courses are all member exclusive and are not shared anywhere else on the internet.